Hello everyone, welcome back to another exciting chemistry video lessons by Adrenaline, the Bazooka Prophet. In this particular video, we are going to be analyzing a question that falls under inorganic chemistry, talking about transition element and the D block element. At the end of this video, every student, every post-UTMite, every WAEC JAM students, at the same time, undergraduates should be able to indicate which of the complexes or which compounds is actually a D block or transitional or non-transitional. So let us quickly go back to the question and address it in a step-by-step approach. The question on the board says, group the following elements as either transitional or non-transitional, and these are the compounds or complexes. At the end of the day, we were told to explain our answers. Now we should understand that transition elements and D block elements are not the same. In fact, we should understand that transition elements are elements, right, with a partially filled D orbital. That word partially is what differentiates a transition element from the non-transitional ones or the D block elements. That for you to be a transition element, there must be in your orbital or in the D orbital the presence of an unpaired electrons or a partially filled D orbitals. While for you to be a D block element, you must have an electrons in the D orbital. And that is to say, in short, all transition elements are D block elements, but not all D block elements are transition elements, because there are criteria that must be fulfilled for you to say or indicate that a particular ion or an element is a transition element, just like what we have aforementioned earlier. So without wasting time, let us do this question in a step-by-step approach. Now, we start, I will break this video into two. So I will start with these two, then in the next video, I will do the next two. So that is how we'll do it to understand everything. So be relaxed, take a seat, take a pen, take a biro, take a booklet, and follow me as I go deeper into these revelations of chemistry. Let's go. Now, pick the first one. This is titanium 4 chloride. The first step is to get the oxidation state, right, of titanium from this compound. So what do? Here is equal to 0. I'm looking for titanium Ti. Take note, chlorine in a compound which is chloride has the oxidation state of -1. So here become -1, right? -1 times 4 equal to 0. So titanium here minus 4 equal to 0, so that titanium is equal to plus what now? 4. So that this is titanium 4 ion, right? Titanium 4 what ion? That is the first step. If I am not able to get for the oxidation state of titanium 4 ion, I can now move to the next step. Take a deep breath. Don't panic. It is actually easy. Follow the step-by-step approach I am actually using. Is that clear? So let us actually continue. Okay. So I will erase the board so I can move to the next step. Now I now have this as titanium 4 now ion. Is that clear? Now what do I do next? I am to get for the oxidation the electronic configuration of this titanium 4 ion. So what do I do? Remember, titanium in its free state is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. This because titanium here is 21 as the atomic number. So this is in its free state. Titanium is having this. Is that clear, Nana? In the free state, this is what, okay, let us see. Okay, sorry, titanium is 20. Okay. Oh, titanium is 22. Please do not make mistake. So here becomes what now? 2. That's very interesting. So what do we do? Now, this is the electronic configuration for titanium in its free state. But you were told for titanium 4 ion. What does it mean? It means there will be removal of electrons. Now, if you have watched my previous video, I have always stated that the removal of electrons, right, is always first removed from the highest energy level here, which is the 4x. Then when you have removed for the x, you can now move to that of the what now? The d. So remember, there will be removal of 2 electrons because titanium 4 ion has lost 4 electrons. Metals lose electrons. So because titanium 4 ion is losing 4 electrons, these 4 electrons is removed first from the x orbital or move to the d orbital. So I'm now having it to be 1x2, 2x2, 2p6, 3s2, 3p6. Now, if you understand it here now, this one is similar to what now? Argon. So, you can now understand here that they're asking you, explain your answer. Please take note. Titanium 4 ion in this complex is what now? Is non-transitional. Right? Because first of all, there is not even a d orbital here to start with. So because there is nothing like d orbital here, this element here now is non-transitional. So the question 1 now has been solved. Please go through the processes in which I used in getting my answer. Is that understood? Is that understood? So let us erase the board and quickly move to question 2. Please take note of it. Okay, so let us quickly continue. Now we'll move to the next one, which is what now? Silver what? Chloride. Now in the case of silver chloride, which is like this, of course the first step is to get for the oxidation state of silver in this compound. So here is now equal to 0. Is that clear now? If here is equal to 0, so silver, of course, chlorine here is -1 equal to 0. So silver here is equal to +1. So that silver is +1 from this compound. I am then going to indicate whether is it transitional or not transitional. So what do? I will first of all, please, I will first of all write the electronic configuration for silver. So silver has atomic number of 47, right? In its free state, which is without charge, silver is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, right? 4p6, 5x1, then what now? 4d10. This is the correct electronic configuration for silver. Silver is an exception. Normally, the one that you know that you put here 5s2, then 4d what now? 9. No, this is an exception to the 4d series. Silver is an exception to the 4d series, whereby there will be 5x1, there will be 4d10. This is in their free state. Is that clear now? Now, if I'm to put an ion here, which is silver ion here, for this one, there will be a removal of electron from here now, from that of the highest energy level here, which is 5x1 here. So here would go away. So I am not having here, so I'm not having here to be 1x2, 2x2, 2p6, 3x2, 3p6, 4s2, 3d10, 4p6, then 4d10. So take note. They're not asking you now, is silver in this compound, is it transitional or non-transitional? Take note. Silver here in this complex is what now? It's also non-transitional. Why? For you to be a transition element, the electrons you have to have should be between D1 to what now? D9. If you are D0 or D10, you are non-transitional. But if you are from D1 to D9, you are transitional. Take note. So because here is 4D10, silver ion in this complex is what now? Non-transitional. And this marks the end of this first part of this video. In the next episode, we're going to be talking about or dealing more about this other one. For now, stay blessed and share this video, like and comment. Thank you and God bless you. Kudos.